Great. Let me share.
We have the pleasure of having the CEO on stage of ChemCubed. ChemCubed, I apologize. Please help me out here. ChemCubed.
ChemCubed. Yeah.
ChemCubed. Ah! I apologize then.
No.
And it's looking very good. Dad, the stage is yours.
Great, great. So thank you. I'm Dan Slep, CEO and co-founder of ChemCubed. Today, I'd like to introduce some of our innovations in printing dielectric layers in multi-layer 3D printing using inkjet printing. A little bit about who we are. So there's a lot of people in the audience that I recognize and might have seen some of these slides before. We are basically a materials company founded around 9 years ago and making specialty materials for additive manufacturing. Trying to figure out how to get the screens going. Within the last 9 years, we've kind of shifted, separated into two different divisions. What we call our nanocube division, which is materials for specific applications, and our electrojet materials and systems for multi-layer printing of electronics. So as I said, we are mostly a materials company. So we have our conductive inks and dielectric inks, but in order to print we needed to have a system to do that. So we've introduced and commercialized a system for printing using inkjet printing for printing the electronics. With that, we collaborate with a lot of people. Some are here. And try to address a lot of these different processes. So we're pretty much commercialized a complete functional system for printing electronics. Our flagship product is our nanoparticle silver ink. I'm just going to briefly mention it, even though the presentation is more about the dielectric innovations we've recently had. But we have our nanoparticle-free silver ink, which sinters at very low temperatures and makes the ability to print using inkjet printing quite nicely for the multi-layer printing. We do offer and have commercialized UV curable dielectrics using this printing stage to be compatible with the silver ink. And these are some of the advanced features of these certain items. As I said, this is our commercialized dielectric ink, and there's still some issues with the dielectric inks to commercialize, mainly because the coefficient of thermal expansion is quite high in regular UV curables, and we're looking at how do we decrease the coefficient of thermal expansion and be able to print functional items at this point. Right now, it's all about the inks. It's all about the materials. The inkjet printing has been around forever, and we do have a system that we promote, but we work on other systems as well. So going to the multi-layer process, what we're doing is we're printing on a given substrate, whether it's FR4 board or flexible electronics on Kapton or even PET, and printing layer per layer on top of that using conductive, dielectric, leaving vias between the layers where needed. And we can even print solder masks. On our system, we have 8 channels, so we can print 8 different materials as we go through this multi-layer process. In this innovation, which is funded by NIST and through an SBIR grant, both phase 1 and phase 2, what we've started doing was knowing that adding CNTs to a system can drastically change the physical properties of the system and thermal properties of a system, of a dielectric. CNTs are carbon nanotubes, sorry about that. So we're adding carbon nanotubes to these systems. The difference of how we're doing it is we're adding carbon nanotubes in a separate